Hello, geometry students. Mr. Gazzato. Today I want to talk about page 21 and page 22 in your notes packet. So we have a learning target to calculate the circumference, area, arc length, and area of a sector of a circle. So before we do that, let's talk about the number pi. The number pi is an irrational number that is approximately 3.14. And let me show you how to find that on your calculator. So on your calculator, it is above, if you press second and the caret key. So you press second, and right above the caret key in blue, you see the pi button. So you press that caret button that's highlighted in red, and then you press enter, and you'll see that pi is approximately 3.14159, and it keeps going on forever. It's an irrational number. So let's take a look at the top of the packet. You may or may not remember that the circumference of a circle is pi times the diameter. Some people will just abbreviate that as C equals pi times D. Another formula for circumference is the circumference is 2 pi r, because 2 times the radius is equivalent to the diameter. That's another formula for circumference. The area of a circle, the area is pi times the radius squared, or pi r squared. I'm going to make that a little neater. So area is pi r squared. So in problem number 1 and 2 and 3, we want to find the area in circumference. So if you look at problem number 1, this yellow line is the radius. In problem number 2, that yellow line is the diameter. And in problem number 3, that is the radius. So for problem number 1, the circumference, you could use either formula. Since I'm given the radius, I'm going to say 2 pi times 16. And if you multiply that out, you get 32 pi inches. Some people like to have the pi in the answer, but if you were to use your calculator, let me show you how to do that again. You would type in 32 second pi, and if you enter, that's around 100.53. So some people leave the exact answer, 32 pi. Other people will say 100.53 inches. For the area, area is equal to pi r squared. So in problem number 1, the radius is 16. Multiplying that out, you get 256 pi. Area is always squared inches, so we say inches squared. And again, if you were to use your calculator and type in 256 pi, I'll show you how to do that again on your calculator. So 256 second pi, you'll get approximately 804.25. So the area is approximately 804.25 inches squared. It'd be my suggestion you pause the screen and try problem number 2 and 3, or if you prefer, you can just listen. So for number 2, I'm going to use the formula pi times diameter because I'm given the diameter. So the circumference is 22 pi meters. For the area, it's pi r squared. And since the diameter is 22, each piece or each radius is 11, half of 22. So the area is going to be pi times 11 squared. And if you multiply that out, you get 121 pi meters squared. I'm going to leave the exact answers here. If you wanted the decimals, you can use your calculator and get the decimals. For problem number 3, circumference, since I'm given the radius, I'm going to use 2 pi r. So the circumference is 2 times pi times 6.8. And multiplying that out, I get 13.6 pi, and the unit would be meters. The area is pi r squared. The radius is 6.8. Typing that in my calculator, I'm going to get 46.24. And I need to write the pi, and then it'd be meters squared. So we just went through finding the circumference and the area of a circle in problems 1, 2, and 3. We now want to look at arc length. So the arc length is given by this formula. It's the central angle divided by 360 times the circumference. So arc length, if you look at this diagram, is the distance that I'm highlighting in red, a portion of the circle, but we're talking about the distance. So arc length is a distance. So the arc length is central angle divided by 360 times the circumference. And so then I could write central angle over 360 times 2 pi r, because that's the formula for circumference. This is the formula for the arc length. So if I were to look at this problem on the right, and I wanted that red length, that arc length, I would say the length, the central angle is 80, so 80 divided by 360 times 2 pi, and the radius here is 6 centimeters. So when I use my calculator and I multiply 80 divided by 360 times 2 times 6, I get 2.6 repeating. So we're going to put that little bar. And then I need to say pi, and the unit would be centimeters. Let me show you how to do that on your calculator. So on your calculator for that problem, you would say 80 divided by 360 times 2 times pi. And notice, oops, I have a typo there. Let me show you how to do that on your calculator. So you would say 80 divided by 360 times 2 times 6. I'm not going to type in the pi, and that's where I got the 2.6 repeating. So it's 2.6 repeating pi centimeters. Then if you were to use your calculator, you could say times pi. And when you hit the times button, it says ANS, so I don't have to retype that. So the arc length is around 8.38. And that would be centimeters. So let's do a couple examples here. In example number 1, we want to find the arc length, and let's say we want to find the arc length of FG. So we need to add of FG. So we're trying to find this arc length here. And we know the arc there is 134 degrees. So if you were to draw in the radii, you know from our previous unit that that central angle is 134 degrees. So we're going to say 134 degrees over 360 times 2 times pi times the radius. And then on our calculator, we're going to type in 134 divided by 360 times 2 times 8. And when you do that, you get 5.95 repeating pi, and the unit would be centimeters. So I'm going to show you how to do that on your calculator. You do 134 divide by 360 times 2 times the 8. We're not going to type in the pi. So I get 5.95 repeating. Then if I wanted to multiply by pi, I would just simply say times pi. And I like to use that answer button that automatically comes up. So we get 18.71. So that blue arc is around 18.71 centimeters. Let's take a look at problem 2. An arc with a measure of 62 degrees in a circle with a radius of 2 centimeters. So this 62 degrees is representing the arc, or excuse me, the central angle. So the length, arc length, technically, is equal to the central angle 62 over 360 times 2 times pi times the radius. So on my calculator, I'm going to do 62 divided by 360 times 2 times the radius, and you'll see you get 0.68 repeating, so it's 0.68 repeating pi meters. And then on our calculator we can say times, the A&S button will come up, second answer. So the arc length is around 2.16 meters. So the learning target on the second part of page 21 was to talk about the arc length, and it is given by this formula that I'm highlighting in pink, central angle divided by 360 times the circumference, and circumference is 2 pi r, so that's how I came up with the blue formula. The arc length is the central angle divided by 360 times 2 pi r. Let's go to the next page. See those darkened arcs, so I'm going to highlight them in red. So I'm trying to find that red arc there. This arc right here in red. And then in the problem number 3, we're trying to find this arc going all the way around. So we know that the arc length, I'm going to write the formula at the top of the page, is equal to the central angle over 360 times 2 times pi times the radius. So in example 1, the arc length would be 120 over 360 times 2 times pi times 9. And if I were to type that in, and I'm going to abbreviate this AL for arc length. So 120 divided by 360 times 2 times 9. We're going to get, that's equal to 6 pi inches, which is approximately 18.85. For problem number 2, we know this green arc is 30, and we have a semicircle here in blue. So the red arc is 150. You get that by doing 180 minus 30. So the red arc is 150 degrees, which makes the central angle 150 degrees. So the arc length is going to be 150 over 360 times 2 times pi. Now in problem number 2, the diameter is 18 feet. The radius is going to be half of that. So the radius is also 9. So typing this in my calculator, 150 divided by 360 times 2 times 9. I'm going to get 7.5 pi feet. And if I say 7.5 times pi on my calculator, I get approximately 23.56 feet. For the third problem here, we know the blue arc is 45 degrees. We know a full circle is 360 degrees. So the red arc is going to be 360 minus 45. And doing that math, you get approximately, actually you get 315 degrees. So the red arc is 315 degrees. So the arc length is 315 over 360 times 2 times pi times the radius, which is 20 meters. Typing that into my calculator, 315 divided by 360 times 2 times 20. I get a relatively large number. Let me double check my math here. 315 divided by 360 times 2 times 20. I get 35 pi meters. And then multiplying 35 times pi, I get approximately 109.96 meters. So hopefully that helps you on arc length. The next video will be talking about the rest of this page. So you'll have to go to the second video.